නැහැ. මොකුත් electron එකක් කියලා දෙනවද? This electron, that electron, no. Then simply we need to check for mathematical violations. If the mathematical rules of these quantum numbers are violated, then that's the answer. What is the answer? Can you see in the third answer? In the third answer, මෙන්න මෙහෙම එකක් තියෙනවා. So these are very easy questions. The third answer says 3, 2, minus 3 plus half. Now what's the error here? You can see when L is 2, ML can be somewhere from minus 2 to plus 2. Can it be minus 3? Can it be minus 3? Link again. When this is L, this should be something from minus 2 to plus 2. It can't be minus 3. That's why it's wrong. Hari? Hari? Send me the link. Hari, if you want, I'll send a YouTube link as well. So you can, let's say you missed something, you can go back. Netana. If you want, you can join through that as well. We had a small delay arranging the link. I'll just copy it to the groups. Dano the groups trigger. Groups trigger in all. No. Okay, if you want, you can join the YouTube live as well. YouTube live. Hari. Right? So this question can be easily answered as the third one because you can see that if when this is 2, this should be minus 2 to plus 2. It can't be minus 3. That's why. Hari, done. And do you have any issues up to now? Isn't the location of if I missed anything, please ask again. Hari, the messages see I'm unable to go through all of this. Already 40 minutes past. Yeah, exactly. When we are having a 30 minutes, 1 hour and 30 minute session, time will fly. So I'll try to discuss few questions and the session will be very quickly over. So chill again, puluwan prashna tika kaba kara and then we leave. That's it. Then the second one. Okay? And what I want you to do is now, since we are trying to discuss now, it's a mixture. I'm trying to give you a certain idea about certain parts. So today we learned a brief idea, or as we revised about quantum numbers. So what you have to do is quickly, if you know that you can't remember the main ideas, you can go and check the quantum number part, or else you will have to relearn. It depends on your level really. That's one thing. And then on the other side, what you have to do is, after you check your knowledge on that part, try to answer these questions again. And then still, if you have any questions, now there can be certain levels, right? There can be students who understand things very quickly. Then for some it might not be. So our responsibility is to guide everyone. Then after the session, you can just send a text to the number I gave you and ask any amount of questions. Then I will be answering those. Hari. So we'll try to have it in a balanced manner, right? Hari. Since we are having the YouTube live, you can even go back and forth. Right, since I gave you a brief idea, now we'll start answering the questions. For the first question, the answer is 3. Second question, the maximum number of electrons having quantum number n equals 3, L equals 2. Now again a very easy question, right? This is the A level. A levels, they ask these easy questions, right? I don't expect this type of questions for your term test. Definitely questions will be much more difficult. For the second question, it says n equals 3 and L equals 2. Then they are asking for the maximum number of electrons. Now, what's the meaning of maximum number of electrons? Now here, as of what we know, when L is equal to 2, ML is equal to minus 2, minus 1, 0, plus 1 and plus 2. And how many electrons? Now what does this minus 2 represent? An orbital. This minus 2 represents an orbital. Right? The minus 2 represents an orbital. Then in this orbital, how many electrons can we have? It can have 0 electrons, 1 electron or 2 electrons. So the maximum number means having both electrons. Now again, that's a point where students confuse. Not sure, there are few ways of that being confusing, but the idea of asking for the maximum electrons is there's only one meaning for that, which is we assume that all of the orbitals are completely filled with 2 electrons. That's the meaning of assuming the maximum number of electrons. So they will always ask for the maximum electrons, because if they just ask for electron, students can think that there is 0 electrons, 1 electrons or 2 electrons, then the answers will be different. So they will always ask for the maximum. Now when n is equal to 3 and L is equal to 2, we have 5 orbitals. All 5 orbitals we have to assume have what? Have 2 electrons each. Have 2 electrons each, which is 10 altogether. 10 altogether. That's the idea. Alright, 10 altogether. So the answer for that is 10. So once you learn the topic, we can very quickly answer the questions. Then what is the answer for that? The fifth one. For 2, the answer is 5. For 2, the answer is 5. Can you please? Those will be discussed in the future. That minus 3. Why minus 3? The previous one. Okay. Yeah, sure. Hari, I'll be quickly discussing this. Most probably. I'll try. And I won't be giving you intervals for the discussion. So if you want me to pause or anything, you can just ask later, or just refer the YouTube live later. Third one. The sets of quantum numbers associated with last 2 electrons of an atom are 300 plus and 300 minus. Okay, that's very easy. Now when you know that the quantum numbers are 300 plus half or else 300 minus half, no need to think of these parts. The main energy level is 3 and the sub energy level is S. That's it. Which means for a given element or a given atom, the final 2 electrons are 3s electrons, which means the configuration should end as 3s2. That's what they are saying indirectly. Instead of saying the configuration ends with 3s2, they have just given the quantum number set. Then what we can say is, you can just check the elements and see what ends with 3s2. It's magnesium, right? Magnesium is the element here which ends with 3s2. Magnesium is 12, which is 1s2, 2s2, 2p6, 3s2. Now it's not about just getting these correct, right? Within seconds you have to get these correct, because the questions they give from other units, from unit 3 onwards, are a little bit difficult, and those take a little bit more time. So don't be happy about getting the answer correctly. These should be you should get the answer within seconds. That's the goal. Identifying these 3 years and then getting the answer. That's the answer for the third one. For the third one, the answer is 3. And I want someone to prepare an answer sheet, and can you send it after the session? So from 1 to this, 2 to this and 3 to this, then I can even post it on the group. Then that's easier for me. Hari. I'll continue. Fourth one. Which quantum numbers N, L, M, L, Ms are associated with the shape of an atomic orbital of an atom? The shape of the atomic orbital. It's actually what? The shape of the atomic orbital. Normally, looking at this, we called it whether it's S or P or D. So that determines the shape. Now that can be a very easy question, but some students might mistake it with this. Now actually the orbitals are represented by this, true, but we determine the type of orbital here. Now looking at this, we can say whether it is S or P or D, then we can say the shape. But there's a small exception. For D orbitals, actually the shapes of D orbitals are different. So we might get the help of this, which is out of syllabus. So I'll repeat. For S and P orbitals, just looking at the L, you can say the shape. Just L is enough. Since we know when L is 0, it is S. That means it's spherical. When L is 1, it's P. That means it's the dumbbell shape. But when L is 2, it's D, but we can't exactly say the shape of D because all 5 D orbitals have different shapes. Then how do we determine the shape? We need the ML as well. We need the ML as well, but that's out of syllabus. So if you check the marking, of this question, you will have both answers as 1 and 5. So you can go for 1 or else you can go for 5. Both are correct. So that's a easy question, but can get confusing because you won't expect them to give 2 answers. Then you might be struggling with 1 and 5 if you know the theory. Hari? Right? Right? Is it clear? Okay. Then what do we have? So that's the fourth one. For the fourth one, the answer is either 1 or 5. The fifth one. The maximum number of electron pairs of an atom that are associated with principal quantum number n equals 3. Now again, that's very easy. This is about this part. Now this is very easy. You can try it on your own. So here you can start like this. See, when n is equal to 3, you have to write all the possibilities of L, then all the possibilities of ML. That's only you can do from here. Then you have the total number of orbitals. How many orbitals do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Since they are asking for the maximum number of electrons, you assume that all the orbitals are completely filled. That's the only meaning of asking for the maximum number of electrons. So you get the answer as 18. That's how we do it. Or else we have learned a relationship between the main energy level or the n value and the maximum number of electrons, which is 2n squared. So when the main energy level is 3, you can plug 3 here and get the value 18 for the maximum number of electrons. Those are very basic theory, right? Then the answer is the fifth one. Sorry, the maximum number. They are asking for the electron pairs. So read it clearly, not the total number of electrons. They are asking for the electron pairs. Then they might have even included the answer 18, but they haven't. Then the number of pairs is 9, which is the answer is 5. The answer is 5. Yeah, they are asking the pairs. True. Then it's 5. The answer is 5. How many questions have we done? This is the 5th question. පහයිද කරේ අපි? Yes. පිටිපස්සේ ඉඳන් එමුද? Shall we come from the 24th question now? And then we'll see what questions we are supposed to discuss. I'll discuss the calculation based ones. And then we'll see. We'll පොඩක් එහෙම කරගමු. හරි? Right? You can hear properly ne? All fine ne? Right, okay. පිටිපස්සින් නම් කරන්නේ මුද ටිකක්. හරි. We have done 5 common like easy questions. එතනම තව සෙට් එකක් තියෙනව නේද? I'll finish 6 and 7 as well. Those are under the same subtopic ne. Then we have 8 and 9. I think come on මෙහෙම යන්න. 6 and 7 උත් කරමු මෙහෙම. 6th. And after the session, if you want me to repeat anything or ask any question, no issue. Hari kisi ප්‍රශ්නයක් නැහැ අහන්න ඕනේ වෙලාවක. I'll help you. The number of electrons in the manganese atom. Now here they have given that manganese is 25, but they might not give you, and then you need to know how to use the periodic table and find that. That have quantum numbers L equals 0 and ML equals -1 r. They are asking the number of electrons. Okay. So for 25, quickly write down this. That's the easier way. Now some might be able to answer this question even without writing this, but kamak ne. Now here, this is the thing. Only for chromium and copper, you have to be very careful when you are writing the configurations. Other than that, it's very easy. Now here, what we have to do is that have quantum numbers L equals 0 and ML equals -1. Right. Now what does that mean? So they are asking separately. L equals 0 means S. Simply that. Then you have to find the number of electrons having S. 2, 4, 6, 8. So the first part is answered 8. Then they are asking for the number of electrons having ML equals -1. Where can we expect ML equals -1? What are the places to expect ML equals -1? First, L should be 1. Then there are 3 options for ML, which is -1, 0, +1. Then L can be 2, and then also we can find -1. Here. Can you see? Now even L can be 3, that's also correct, but L3 won't be in our syllabus, so we have to just, but L equals 0 isn't an option, right? This is not an option. This won't give you ML equals -1. Then if I take this, P means L equals 1. Then you have 3 orbitals. -1, 0, +1. How are the electrons filled? We have 6 electrons, which is this. This is not how the electrons are filled, but yes. Then you have 2 electrons of -1. Here also the same story. P means L equals 1, then you will have 3 orbitals, and then you will have this amount of electrons filled here. Done. Ekath hari. Then here L is equal to 2. Then you have 5 orbitals. Now here you need to be extremely careful. Now these are the notations of the orbitals. Hari. But how are the electrons filled? If you start writing like this, which is wrong? No, what's the rule we are going to violate? The Hund's rule. According to Hund's rule, we can't use like this. Then what are we supposed to do? Then we only have 1 electron having L equals -1. That's it, right? That's it. So you have 5 electrons altogether where L is equal to -1. Then this part we got the answer as 8. This is 8, and then for here we got the answer as 1, 2, 3 and 4, 5. Even here this is the same story for this one, same for this one. So there's 2 plus 2. There's another one which is 5. This is the story. Then the answer will be 8 and 5. Be very careful. There can be answer saying 5 and 8. So it's 8 and 5. The answer is 3. The answer is 3. Tuna. Harida? I think you can do the 7th one on your own. That's not very difficult. So it's just a combination of some things we have done up to now for the first 6 MCQs. And then try to do the 7th one on your own and get the answer. Now you can check the answers because these are past paper questions. Answers are provided always. And you can complete it. And here's the thing. What I expect from all of you is, in A levels, the easiest ways to success is just don't make the same mistake twice. That's it. No need to be super smart and no need to avoid mistakes. All of you will make mistakes. There will be only a very few amount of students who do not make mistakes doing questions. Maybe that number is even 0. So what you have to do is just understand the concept and make sure that you do not repeat the same mistake. That's the only thing you need to do. If you are able to do that, then I think most problems will be sorted. Right? Okay. Then I'll start discussing from the other end. I think I have discussed some theory questions. Sorry, the calculation questions, and then you can try 8, 9, which are theory. 11 again theory. There are some theory points. First we'll try to finish the calculations, and then we'll see what we can do about theory. Okay? If everything is correct, fine. Then up to 7 completed. Right? Then I'll come from the other end. පිටිපස්සේ ටිකක් කරන්න. Since those questions are little bit more difficult. Can you do some calculations related with equations in first unit? Because yeah, you mean the last questions, Neil? That's the requirement most students are. How observes no wavelength of green light to answer question 10. Hari, I'll be answering those questions. Dala the questions. If I missed anything, please. And there's a text few times sent asking to cover the ionization part. I think that's not in this tube today, so we'll be doing it next week. So anyway, we have more than enough time. In the mega me hammer week game karna. And most things will be covered again and again. Sorry. Okay. The 24th. Right? Okay. There's one more thing everyone should understand. Now, when I'm doing a discussion, I am varying the pace, especially in an online class. Now, in a physical class, I vary the pace looking at the students' expressions. So, if you are struggling, I slow down. If you are finding a little bit too easy, then I'll speed up. But in online class, I simply assume the level you should maintain. So for easier questions, I will do the discussion very quickly. So if that pace is too much, that means you have to improve. Especially for the first few questions, if those were difficult, if my pace was a little bit too much, first step, just ask for the recording and go through it again, or use the YouTube live, whatever. But that's an indicator where you should improve. Have those indicators. Right, then from the 24th. The 24th question says, the de Broglie wavelength of a neutron traveling with a velocity v is lambda. If the kinetic energy equals half mv square of this neutron is increased 4 times, the new de Broglie wavelength will be. What does that mean? So they are saying for a neutron, the wavelength was lambda. Right? The de Broglie wavelength was lambda. And then the kinetic energy has been increased by 4. They have given an equation half this, you know from O levels as well, half mv square. They are asking if I increase this by 4 times, what happens? That's the idea, right? If I increase it by 4 times, what's the de Broglie wavelength? Now, what we know is, we know few equations. We know lambda equals h over p, which is the de Broglie equation. So whenever you get a question, you can have several approaches. One of my approaches is write down all the equations I know which contains lambda and see what's the relationship here. Because we can't see any lambdas here, right? But they're asking all of a sudden, if I increase or if I multiply this by 4, what happens to the lambda? We can't see any relationship, so we'll try to build one if there is any. Then I have another one, C equals F lambda for a electromagnetic wave. For a normal wave, it's V equals F lambda. Maybe this has something to do. We don't know. We'll see. But P can be written as, what is P? What is P? P is momentum, right? P is momentum. So I can write it as mv. And I prefer using this equation. Why is that? Now these are logical decisions. Now you might just randomly select this. But if I ask why not this, what's the reason? If I use this for this calculation, I mean my argument can be wrong, but this is how you start arguing, right? My argument is, then there will be another variable f, then we'll have to deal with that. But here, if I simply go with this, h is a constant, mv is already here, and lambda is what they're asking. So, okay, not an issue. Using that will be much more easier. So what I'm going to do is, I'm going to include lambda here. Then how am I supposed to do that? The easier way would be, what do they have? They have the kinetic energy. The neutron traveling with the velocity v is lambda. The kinetic energy of this neutron is increased by 4 times, and then they're asking for the de Broglie wavelength. Okay. Any idea on how to progress? How can we progress? Yeah. So the easiest way is okay, the easiest thing to do is actually think like this. When I multiply this by 4, if I multiply the kinetic energy by 4, what does that mean? That means the velocity has been increased by 2. Why? Because for a neutron, can the mass change? No, mass is a constant. So you need to realize that very quickly. Then multiplying this by 4 is multiplying v by 2 because they are the square. Then when v is multiplied by 2, again this is a constant, this is a constant. Then when you multiply this by 2, what happens to this lambda? It will be multiplied by half because here v is here and lambda is here. You get the idea, right? It's on the two opposite sides of the fraction. Then when this is multiplied by 2, lambda is multiplied by half. Therefore, the new lambda is lambda over 2. That's the easier way, other than just writing equations and subjecting and all. If you have that idea where you can start from here and go here and do all that, take a lazy. Try to improve those ideas. Now, some these might be very easy things, but I know most of you are struggling to think like that. This multiplied by 4 means this was multiplied by 2 because this is a constant. When we multiply v by 2, lambda will be multiplied by half. That's the idea. So the answer will be L lambda over 2, which is the first one. Now again, I repeat, the goal is not to somehow get these correct. The goal is to get these correct quickly. මේවා ඉක්මනට ගන්න එක තමයි වැඩේ. හරි, keep that in mind. Right? When you start online theory classes during weekdays night, you can be more happy as well as it is. Okay, send those requests to the WhatsApp number. I didn't get how v was multiplied by 2. Okay. Now මෙහෙමනේ. I'll repeat again once more. When we multiply E by 4, so they are saying that this is the equation for kinetic energy, right? This is the equation for kinetic energy. This was multiplied by 4. What does that mean? Now we know the neutron, so this is defined for a neutron, right? We can't change the mass if we want, even if we want, for a neutron, can we? Mass එක වෙනස් කරන්න පුළුවන් නේද? So they are saying, they are asking for a, they are only saying not a sample of neutrons, right? Only one single neutron. So the mass of that single neutron is a fixed number, it's a constant. So this can't be changed. In this equation, to multiply this by 4, what factor should be multiply v by 2? Because when we multiply v by 2, since it's a square, let's say this was 5, this was 5, 5 squared is 25. If I multiply this by 10, by 2, then it's 10. 10 squared is 100. Even though I have multiplied it by 2, this gets multiplied by 4. That's what I said. So when this is multiplied by 4, this needs to be multiplied by 2. Am I good? See whether that is okay, whether you can understand that. Right? බලන්න එක. There was a text saying that the answer was given as 2 lambda. That's an error in the resource book. I mean, in your Pesuru book. English medium Pesuru books do have errors. Hurry for answers, so be careful. Hurry. So when v gets multiplied, so if you check your past paper book, 18, the answer is 1, not 3. Any concerns? Hurry. You can check it again and you can ask later. Although v is multiplied by 2, it exists as half. What does it mean? Green light question, please. Where's the green light question? Wait, we'll do that. That's the 10th question. I think I'll have time to finish all the calculations. We'll give it a try. Omega. Then the 21st one. We see any questions on 14 and 15. What's 14 and 15? Calculations? Ne? Yeah, hurry. This is done. Ne? Then we have the 21st. A lamp produces 6 joules of energy per second. Now that those things can be missed per second in a blue region, 479 nanometers of a visible light. For how long should the lamp be lit to generate 1 into 10 to, that should be 1 into 10 to the power 20, not 1000 when you get the idea, right? It's 1 into 10 to the power 20 photons. Sorry. So that should be corrected. The number of photons hasn't been properly typed here. It should be 1 into 10 to the power 20 photons. So it's very easy. Just use E equals HF. And what we have to do is a lamp produces 6 joules of energy per second. The idea is you have to find how many photons are released per second. So the first goal is to find the energy of one photon. This equation gives us that. So you have to use 6.626 into 10 to the power minus 34. Now normally these values will be given in your papers. Sorry, but I'll just give it here. And then the frequency hasn't been given, so you have to use it. E equals hc lambda. Check whether you know how to derive this equation. Then c is this. Then lambda this. Lambda is given actually 470 nanometers. Be very careful with the unit conversions and all. Now these questions again, try to do this very quickly. This is the amount of energy you get per photon. One photon will give you this much of energy. Mecharak energy from one photon. Right? So you multiply these and you get the answer. Right? Or else have they given it? So you have this. Now they have given us the amount of energy released per second. Now this can be given in another way, 6 watt, right? Now if they give it like this, you can't be confused. Now they have been generous here, given it like this, but what is joule per second? Now this is in joules. Now here see whether you can understand this idea. The energy of one photon is this. The energy emitted per second is this. Then if I divide this with this, I would get what? The amount of photons emitted per second. Can you process that? Is the whole thing making sense? Per second, it releases 6 joules. Hari, if you want, I'll just simplify this now. For the moment, I'll use the calculator, but you can't use the calculator to make things speedy. I'll just use it now. Just to show you things, I'll make but normally, if you understand the process, no need to even simplify this. You can continue and simplify later. Anyway, make a multiply gram, you get this, and then you have 10 to the power 17 and 10 to the power minus 17. That is 4.22 into 10 to the power minus 19. Something like this. You will get something like this. If I simplify this, I will get this. What is this? This is the energy of one photon. Right? But how much energy is released per second? 6 joules is released. Per second, 6 joules is released. Then we can find this. the number of photons released per second. Now this is why it's very important, students, not to just use equations to solve questions. Now that's a main error. I think I informed this on the first day of unit 3 last week when we started that. ඔගොල්ලෝ ගොඩක් පුරුදු වෙලා ඉන්නවා to use some equation to get the answer instead of just understanding what's going on. එහෙම බෑ. You need to clearly understand what's going on. Now here to calculate this there isn't an equation. මේකට equation එකක් නෑ ළමයි. What you have to do is you need to understand 1 second will give you this much joules and 1 photon will you give this much energy. Then how many photons are produced in a second? How are we supposed to get that? By doing this. බලන්න මේක තේරෙනවද කියලා? This will give you the amount of photons we get per second. This is the amount of photons we get per second. බලන්න එක ඕකේද කියලා? Now that is a thing you need to understand. Think it over and over. If you can't figure it out, ask again. It's 1.24 into 10 to the power 19 photons per second. This is the amount of photons it produces. Now it's pretty easy. Now they are asking how much time will it take to produce a given number of photons. The amount of time you can calculate. They have given this much of photons. This is the target, and per second that much of photons will be produced. Per second this much of photons will be produced. So divide it and you will get something less than 10. Why? Because this divided by this gives you 10. This divided by this gives you something less than 1. Therefore the product should give you something less than 10. බලන්න ඒවා එහෙම තේරෙනවද කියලා? Then you will get 10 over 1.42, which is 7.04, approximately 7.1 seconds. But once you understand, now the importance of understanding the whole process is, now if I did this question, now I simplified this you to show the idea. But if I did this question, I won't simplify this. I will completely take this somewhere and put it and finally do the simplification. Then since this is MCQ, maybe looking at the numbers, we have done this in classes. Looking at the numbers, you can just do what? You can maybe guess the answer instead of just simplifying and wasting time. But here I had to just show you the value and to make this sense. Right? එහෙම මේක තේරුණාට පස්සේ instead of simplifying this, you can just plug this entire thing here and then simplify all the powers of 10 and then maybe you have a chance of guessing the answer. Try to do those once you get a better idea about this question. Sorry. Now that's the, what is the question? (2017-12). That's the 21st question and the answer for that is 2. For the 24th, the answer was 1, right? Then I'll do the 17th. The next question will be 17th. I'll do 17. I'll do 16. Even in 16, the 10 to the powers haven't been properly typed. It's 10 to the power 14, 10 to the power 14. You get the idea, right? 10 to the power 12 එක හදාගන්න. Others have been corrected, I think. පොඩ්ඩයි නේ තියෙන. I'll do those shape එක. හරිද? Fine. Then shall we move on? මේවා මෙහෙමම තියෙනවා. So if at any point if you want me to switch to any slide, කියන්න shape එකේ I can. So I have the 21st. Then we can do the 17th maybe. It's not a calculation. Sorry. Hari? The 17th question. What does it say? The maximum wavelength of light that can produce this effect. What is it? What is this effect? It's about the. Okay, Hari. This is from the 16th. Okay, we'll do 16th and 17th. Question 16 and 17 are based on following paragraph. Read the graph carefully and select the answers for the questions. Now you will learn these concepts properly in physics when energy is given to a metal, electrons can be released from the surface. If that energy exceeds a certain limit, from metal to metal, that limit is different. Metal to metal, the limit is different, but there's a concept which you will learn in physics. I can't really remember the name. I think that's the photoelectric effect. Okay, 14 please. Chill. Yeah, photoelectric effect, exactly. So you will learn about the photoelectric effect. The idea of the photoelectric effect is for every metal there is a cap, or not a cap, there's like a limit. If that limit is exceeded and we give more energy, if that basic requirement is exceeded, electrons will start to emit from this surface. That's the idea. Even in the cathode ray experiment, that's what we actually do. So you have the cathode, and once you provide that high voltage, electrons will be removed. It's actually the photoelectric effect, it's something like that. But you will learn the proper mathematical ideas later, and then they have explained about that. So comes it attracts positively charged nucleus. It may escape from the surface. That's the explanation. The minimum energy required for the electron to escape varies from metal to metal. So that's the concept. 16. The energy required for photoelectrons to be ejected from the surface of barium is. The energy required for photoelectrons to be ejected from the surface of barium is 240 kilojoules per mole of electrons. Minimum frequency of light capable of producing a photoelectric. Now they have said a whole lot of things which are totally unnecessary, right? Just to mislead you. It's just you need to find they're asking for the frequency, the minimum frequency, then plug this equation. That's it. So you have 240 kilojoules. Why are they asking for a minimum frequency? Because if this frequency drops below the minimum, E will drop below whatever the value we are doing the calculation. So we have to assume that the minimum frequency is found at 240, because 240 is the minimum energy. The minimum energy is 240, so we have to find the frequency to that value. 3, H is this. Then you can find the frequency. That's it, right? But no, not actually. Why is this equation wrong? Because they are asking for a mole. That 240 value is given per mole, right? Yeah. So this is wrong. This is what most students will do. Why? Because they are asking for a mole. Then when they are asking for a mole, you have to substitute like this. 240 into 10 to the power 3 is correct. But here, this is the energy of 1 photon. This is the energy of 1 photon. මේ තමයි එක photon එක energy එක. And this should be multiplied by the Avogadro constant. This should be multiplied by the Avogadro constant. ඔන්න multiply වෙනවා. Then you can solve the value of f and get the answer. I won't simplify. But again, now to do these simplifications, okay, I'll just show you few things. 240 into 10 to the power 3 divided by, if I simplify the powers of 10, I will get 6.022 into 6.626 into, multiply it's 10 to the power minus 11. So if I simplify these powers of 10, I will get 10 to the power 14. So I have this. මෙන්න මේක තියෙනවා මට. හරිද? මෙහෙමයක් තියෙනවා. හරිද? Now, one thing I did those days to improve my time, I remembered the value of this product. I remember, now that's not a very smart thing to do, but somehow I wanted to save time, therefore I remembered the value. Now I can't remember, it's some 39 point something. So if it is approximately 40, what do we get? 240 divided by 40 is 6. So the value is something 6.0 something into 10 to the power 14. Since the answers are given as whole numbers, it's 6 into 10 to the power 14, which is 4. So you can do those things now. That might not be the smartest thing. Some can say that's stupid, true, but it saves time. Right? No? At the end of the day, if you are scoring and if you are managing time, no one cares how you do it, right? So the product of this is some 39 point thing I can't remember. Try to be creative. Think of ways to improve your speed, think of ways to improve your calculation, think of ways to improve your memory. Actually, they have provided you 2 hours or 2 years or more than 2 years for A level to do those, not to cover the syllabus. Honestly, the syllabus can be covered within a year because for the revision students, we do cover the syllabus within a year. We don't even have 1 year for them, but we somehow manage to cover the syllabus. We do it properly even. The difference for you is you get more time to improve yourself, to actually being capable of doing things and memorizing or improving your simplifications, going and trying to aim to the best result. Otherwise, for a C pass එකක් වගේ මේ 1 year, even 5-6 months is enough. But to get better results, to get to a better position, you need more skills than just finishing the syllabus. That's what I try to always improve. Hari, ඔන්න ඕක බලන්න පොඩ්ඩක්. You can get the answer here. That is for the 16th question. May I will 16. And then you can get the answer for the 17th one. They are asking for the wavelength. Now here they are asking for the minimum frequency. We know that if the frequency is minimum, now here you got the answer as 4. If the frequency is minimum for the 17th question, it's C equals F lambda. So this is a constant. When this is the minimum, this is the maximum. That's why they have given those minimum maximum terms, right? Then you know the frequency which you can plot here. Plug karanna mehema. C value you should know, they normally give it, and then you can get the lambda value. You will get the lambda value here from meters, then you have to multiply it by 10 to the power 9 to get it from nanometers. Ne? So it's 0.5 into 10 to the power minus 6. 3 10 to the power minus 6 meters. When you multiply it by 10 to the power 9, you will get 500 nanometers. This is the maximum lambda value you can get. So the answer is the third one. What's the time? It's almost 10:30. We have 13, 14 and 15 and 10. Those are the only calculation questions. We have 10, 13, 14, 15. We'll take another 10, 15 more minutes and I can finish those. So all of these sessions will be highly concentrated, productive sessions. Within 1 hour and 30 minutes, I'll do set of questions like this. So I think what we learned today is I'll send the PDF a little bit earlier, and then you can do those questions, and even you can mark your answers and then come prepared. If you are unable to do that, let's say you were unable, still join and listen. I think, but if you do those, it will be much more better. Then you have a better understanding on what you have, what you know and what you do not. Shall I move on? Then I have 15. The de Broglie wavelengths of two particles x and y are 1 nanometer and 3 nanometer respectively. If the mass of x is 3 times the mass of y, the ratio of kinetic energies of x and y would be. Now that's very easy again. Now since we have some experience on these type of questions, for the 15th question, So this is the equation for kinetic energy. Now have they given that equation? No, ne. Dilat naha ne equation එක. No. So they expect you to know this. And then for lambda, you know it's h over mv. Now when they are asking for a comparison, now in the previous question it was only about a single neutron. It was only about one element. So I can say this gets multiplied by 2, then it affects it like this, and we can try. But when they give two elements or else two things to compare, it's easier to have one single equation to do the comparison. It's easy. Otherwise it will be a little bit more time consuming. So what I can do is, now what are the ratios they have given us? They have given something about the wavelengths, and then they have given about the mass. Have they given anything about the velocities? No, right? They haven't given anything about the velocities. Which means they don't care about the velocities. Then we can cancel out the velocities. How am I going to do this? I am going to subject V. Try to learn these new concepts. I am subjecting V, then I will get V equals h over m lambda. Why am I subjecting V? Because I am going to substitute this value here. Because I don't need V, because they haven't given anything about V. We have to simply get the idea about the kinetic energy looking at the masses and the wavelengths. That's why. Then I can say E equals half m. Instead of V, I can write this h over m lambda squared. H over m lambda squared. Then half m h squared m squared lambda squared, and I can simplify this and write half h squared over m lambda squared. This is the equation. See whether you understood. Generally when they are asking for such a comparison, the approach would be this. Write the two equations, but it's easier. Now in the previous neutron question we didn't do this much. I wanted to do this, but I understood since we only have a neutron, we can just easily compare and get the answer done. But here, when we have two elements to compare, it's little bit easier. Make a V subject kara, we plot it. Why specifically V? Because they haven't given V. Then we can't have V in our equation. Then we can't do the comparison on no equation. Then I have equation which says E equals this. Now I can do the comparison. Now they are saying if I compare x and y. If I compare x and y, now this is my equation. My equation. If I have x and y, right? If I have x and y, what do they say? The wavelengths are 1 and 3. May then wavelengths. Shall I? Wavelength is 1. Now no need to think of the units unless the units aren't the same. Units same. Wavelengths are 1 and 3. The mass of x is 3 times the mass of y. Then if the mass is 3, read those properly. This is the distribution. This is the lambda distribution. This is the mass distribution. This is the lambda distribution and the mass. Now see what I am going to do. Instead of substituting all of that, I am going to write something like this. I am going to write Ex, which is the energy of x. Now this is a constant. Can we ignore? Yes, because it's constant. Now we are trying to compare. So no need to compare the constants. This is again a constant. No need to compare. Then I can write Ex is directly equal to 1 over, what is it? M is 3. 3 times 1 squared. Now is this mathematically correct? Not at all. You can't write it like this, but since this is MCQ, no one will check your work. I just ignore the constants. Try to learn these methods. Now it might be more comfortable for every one of you just writing this as x, 3x, y, 3y, and substituting those values and writing equations for both the kinetic energies and then dividing and getting the answer. It might be more comfortable, true. But that is more time consuming. Try to get used to this method. Ignore the constants and then look at the format of the equation and you can do this. Here lambda is 3, m is 1, then 1 over 1 times 3 squared. Now what they are asking for is the ratio between Ex and Ey, which means now the ratio between this is this, right? Ex over Ey. So the one in front should be here, this one should be here. This is how we divide Ex over Ey. Right? X to y is Ex over Ey. Then you have to divide this by this. Then you will get the answer as 3. Ne? This goes on top. Yeah, 3. Oh my God. Okay. Whether that's okay. Can you send the slides of the calculations to the WhatsApp group after this? I can, but will you understand? Or let's just send a text. I'll just send it to you personally. Well, YouTube live you can watch that later as well. Even this recording, up to you. Here we have this. So EX over EY gives you 9 over 3, which is 3. Now see whether you know how to divide these simple ideas. So EX divided by EY is this divided by this, then this goes on top, and then it's 9 over 3, which is 3. Now if your simplifications aren't that good, try to improve those, because that plays a major part in your A levels. Simplifications will be very important. Why did you ignore the constants? Because they are asking to compare. Now, when I am comparing, these values will be the same for here and these values will be the same for here. So those will just cancel out. That's why I simply ignore the constants. Constants ignore color, you can just look at the variables and plug those and divide it. That's the actual line. So the correct equation will be this. Ex is proportional to 1 upon 3 over 1 squared. Because I can ignore the constants. But since this is MCQ, no point writing all these proportionalities on. You can just write this and divide. But may concepts, try to understand this. Just don't say, these are difficult, I'll just use the method I prefer. That's one mistake students make. Try to break through your comfort zone. Because most of your comfort zone is time consuming. Substitute, you divide it and slowly get the answer. That's why you tell that time is not enough for a paper. Because you don't use these methods. Comfortable unada passe, very easy. Hari? The answer are in the ratio. Okay, they are okay. If the answer is in ratio form, yes, 3 means here this is 1, this is 3. True. Then it's 1 to 3. I didn't check the answers yet. If the answer is in that ratio, yes, it should be 1 to 3. True. Then it's number 2, right? So they are asking EX to EY ratio. Then EX is 1, this is 3. EX. It's the other way, right? Isn't it the other way? So did we get the equation correctly? Simplifications are correct, right? Lambda equals h of mv, so v equals that, and then this is this, and then you get a in, right? Then what has the higher lambda should have a lower e value. Then y should have a lower e value. It's 3 to 1, not 1 to 3, isn't it? It's 3 to 1. That's why we got 3 as the answer. Yeah, it's 3 to 1, right? It's not 1 to 3. Now, work on the ratios properly. Now, may. After you do all of these and get the ratio incorrectly, that's terrible. Now, this is the idea. Now, they are asking EX to EY. So, EX is that 1 over 3 times 1 squared to 1 over 1 times 3 squared. Then how are we supposed to simplify? It's 1 over 3 to 1 over 9. Then how are we supposed to get the ratio? Multiply it by a common factor, multiply it by 9. Then you will get 3 to 1. That's how we get it. Multiply it by 9. Okay. Hurry. Then shall I do the 14th? Hurry. I'll give you like 2 minutes to complete this. No need to even do the 13th one. Which of the following electronic transition belong to the visible? That's anything ending at 2 will belong to the visible region. And since we are focusing on the emission spectrum, it should be from a higher value to a lower value. So answers like 1 isn't correct. It should be answer 2 for the 13th. It's very easy. Right? I think the 10th one you can't do is maybe there's a typing mistake there. Okay, just finish this part while I'll check that. Yeah, actually we have missed it. There's a small error typing mistake at in the 10th question. The one part is missing. They have given the wavelength. The wavelength is given if that was the concern. In the 10th question, they have given the wavelength. It should be 4.42 into 10 to the power minus 7 meters. In the 10th MCQ, you can write this down. Lambda. Right? Then that's not a difficult question. Then you can easily get the answer. So I meanwhile the others are writing the explanation. I explained two things. The 10th question, the lambda is missing on the paper, so you can include it and try to do the question, which is easy. We did those kind of questions now. And then the 13th one, the answer will be 2. The answer 3 is wrong because we are discussing only the emission spectrum. So the transition should be from higher levels to lower levels. And the 14th question is remaining, which I'll do, and I think that will be it. And then we'll talk a little bit about the session and we'll wrap things up. හරිද? What's the issue in the 14th question? It's just a normal question, right? You just need to, since they're asking for only one photon, you can use this equation. And then, isn't the value there? Then C is this. And then they have given the lambda value, which is 1.1 centimeter. You have to convert this to meters. Then whatever the value you get here is the answer. That's all right. What was the issue there? Check what is the issue, right? බලන්න මොකද්ද case එක. Right? හරිද? Check whether this is okay. Here also you can try to do some now here you can see the answers are not that difficult to no need to do the simplification here. Why? මේක බලන්න. Here you get a 10 to the power minus 24 and arrange all the other terms. You have 6.626 into 3 over 1.1. මේ බලන්න. Now here look what I'm going to do. If I simply ignore this part, now you can see the MCQ answers aren't that competitive. When you have a question where the answers aren't that competitive, you can try to do some things. If I ignore this small part, which is a very small value, right? 0.026, a podi number, then 6.6 divided by 1.1 is 6. Then 6 into 3 is 1.8. Sorry, 6 into 3 is 18. Then 18 into 10 to the power minus 24 will be the answer, which is 1.8 into 10 to the power minus 23. So that should be the answer. Answer it's 1.8 some small value into 10 to the power minus 23. Sorry. Then the answer is 3. Try to do those. But then the answer should be competitive. If we had answers like this, then you can't. So looking at the answers, you need to have the awareness to know whether you can do this or not. How do we find group number, period number, questions? Yeah, those things will be covered later. Now there are a few questions related to ionization and all. Those things will be covered in the next few sessions. So all the past paper questions, now I think this is also done. Now all the past paper questions from 2012 onwards. Now as I mentioned, I will be mainly focusing on that region from 2012 to 2024. Since we don't have 2025 or 2026. So those 13 years, all the past paper questions will be given as question-based revision tudes to the group, sent to the group. and most of the questions will be discussed. Now even today we discuss most of the questions, and from the remaining questions, if you have any doubts or any important ones, I can continue it to the next week as well. So next week you will get a separate set of questions, but yes, past paper, all the past paper questions will be discussed. Even 10 questions or 15 questions per day is 60 questions per month. මාර ලොකු quantity එකක් කරනවා හරිද? That's why joining all the day every day is important, not joining one day. එක දවසක් ඇවිත් වැඩ නැහැ අතර මේ sessions වලට. It won't be that productive. Yeah, the graph and so කරන්න. Yeah, those will be done. Hari? Because first I will try to do some past papers, but next week I'll include some term test questions. So those two have some gap. Some term test questions can be extremely difficult and extremely time consuming. Maybe when we are doing only term test questions, maybe 5 questions per day will be the limit. It might take some time and it might need some more revision and some more basic ideas. Possible. Hari? Okay. So I think what questions haven't we discussed? Mainly the theory we did not discuss. Ne? The 8th we did not, 9 we didn't, 11, 12 we didn't, 19, 20 we didn't, 22, 23 we didn't. So the theory ones are left. Sorry? And I think that's enough. So you can work on the remaining theory ones and then you can mark your answers. Next week I'll make sure that the paper is sent a little bit earlier, then you can do those, mark the answers and try to join every week. That will improve you a lot. You won't notice the improvement in a quick time period, but after 2-3 months you will have a clear improvement. Because for let's say 15 questions per day, 60 questions per month, around 200 questions in 3 months. It's a massive number, right? Without that much of effort. Now you just join and listen, chill again, 1 hour 30 minutes and you leave. That's it. That's the concept here. Without putting that much of effort, slowly trying to do a lot of questions. This will never be a session which is 3 hours, 4 hours. This will remain 1 hour and 30 minutes forever. Yeah, any feedbacks, anything? What do you want me to do in the future? Now, if you have it, you will keep it unit 2. Yeah. I think I informed those the things related to the classes, the unit 2 paper discussion, unit 2 tube discussion, all of those will be done. Yeah, before you leave, any feedbacks, anything? And there were few questions related to the classes. Don't ask here. Just send a text to this number. Then those things will be asked related theory classes or anything. This is just a normal session I just have for fun. Yeah. Anything you want me to do? More calculations from unit 1? Yeah, there are more. So this is not over. Making unit 1 isn't over, right? There's a lot more topics to cover now. The ionization parts, electronegativity part, none of those have been covered, right? So all of those will be covered. So even for past paper questions and definitely term test questions will be covered. Anything else? If you don't have any feedback, you can start leaving, but you can listen to these feedbacks as well. Up to you. Feedbacks. Yeah. It was really good. Use smartboard if possible in theory class as well. Really? The main issue using the smartboard is do questions from unit 2. Yeah, okay, we'll first finish the unit 1 and Balamuhi, like next week if I feel having unit 2 questions are also better, I'll include Balamuhi. Not sure whether combining all of those will make it efficient. The issue using the smartboard is you won't realize it oftenly. Especially doing calculations, the amount of room isn't enough. Then we need a massive one. I'll if I have the ability to do that next year, I'll buy a larger one. Then we can have some fun with it. Yeah, otherwise, the issue is the amount of space isn't enough. Then for some students who can't memorize the previous step, it might be difficult because I'm doing this and this. It's difficult. That's the only concern. I think can try. Our school only have smart boards. Really? It was good. Keep doing this great work until our A levels in 2027. Yeah, if you are participating, of course. I'm just doing this for fun to improve you. You said that you have this 6 month exams this month. No, next month. Next month, first week, I have exams. But still, the classes and all we have, right? Classes you are then. maybe some classes we'll have to delay the time because I think I have not sure exams from on some Mondays. I think according to the predicted schedule, we don't have a finalized timetable. It's from 1 to 4 p.m. Then I'll have to write the exam and start the class at around 4:30. Okay, this is not this month and this is not confirmed. Just since you asked me next week, okay, sorry, next month. I think some weeks we'll have to have the class from 4:30 onwards instead of 3:30 onwards. Sure, if the timetable changes, බලමු. Main chat එකේ දාන්න එපා robot smart boards at school. Yeah, most schools do have, I think. See, that's why I don't allow the main chat. ඔල්ලොන් ඩිනා වෙන්න එපා. What else? Any other feedbacks? Yeah, even my school has lol. Okay. It's not about the method you learn, it's about whether you learn or not. Okay, anything else? Anything else you want to let me know? මොනාරි තියෙනවනේ feedbacks දාලා තියන්න. හරිද? Man, the only feedback I really got was to continue this forever. Okay, I'll do that. And to send the PDF a little bit earlier, then you can answer the questions, and to include some unit 2 questions and past paper term test questions. Ne? That's it, right? Okay. We secretly watch movies in smart. Even I do that. I play karaoke and sing songs. Next level fun. I try to afford a smart board later. Next level fun. True. I think that's enough. Okay, now you can leave, I think. Otherwise, we'll be chatting here. Young Kattiya. Thank you, so. Okay. Looking forward. Okay, sure. Good night. Okay, good night. I feel better when you give answers for theory questions too. Okay, we'll do that next week. You can leave. I'll just read through the messages. Do you remember your honor sheet? I know that you wrote that you invented new answers as question. I can remember the name. Nammathakai mata. Other than that, what was the honor sheet? Not sure what you are referring to. Dala diyanna, if that's. Okay, can remember. I can remember most of your names now. Last week Monday, what was it? Can't remember. Young. Thamat inno obadu bahagena. Young, we'll meet on next Saturday or next Monday or whatever the day you are coming to classes. Okay. This session is very useful. Thank you. We'll continue this. That's it. Thamat dinada. That's it. Is that it? Good night. Okay. Okay, then I'll end the session. Good night. We'll meet on next week. Bye. See you.